Hello everyone, welcome back to Power System, class 19, part 2. Um, Remember last part we did a power system example where we don't have any losses, we don't have any limits on the power generating plant. Now we're gonna have a limit for power generating plant. So we have the limit here for power generation max and min, so you cannot cross those limit, right? So this is the cost function or incremental fuel cost function for in between the limit. But if you hit the limit, if you had by max limit, your function become less than lambda. If you hit the minimum limit, your function become greater than lambda. What means this one saying over here? If you reach a limit, if you reach a limit, you become pegged at that limit. Okay, that means you now generate the limit amount, and you need to take your power plant out of the solution at that point because you don't have any more adjustment. All right, so let's talk about this. So it's the same thing here. You always look at your power generation should be equal to power demand, and you always check that delta P. So when delta P is 0, you reach the solution, right? All right, so again, you said if any plant reaches the max or min, the plant becomes packed at the limit and constant output, and only unviolated plants must be processed in the solution of iteration. All right, so I have 3 power plant here. Now I have a demand 975 megawatt, and I have the limit here now, right? Max limit and min limit for each of the power plant. So my initial solution, I'm gonna start with the 6 over here. So let's go ahead to the 6. Then I'll calculate each of the power plant output at that initial solution, and I found that is obviously a lot lower than demand. So lower than limit. So I'm gonna find the next delta lambda 1, and I'm gonna add that to my initial one, and I got the next one. Then I put it back here and do the same solution again. I found that all 3 values, and I also found that I met the demand equal to production. But there's a problem here. Look at here. It's 482.89 megawatt. But remember that my power plant 1 cannot generate more than 450 megawatt, right? So I basically reached the limit here. So I cannot go over 450, but I have 482 here, right? So that means at this point, my power plant 1, it should be equal to 450 megawatt and stay there, constant output. And that is not a part of the solution in my iteration right now. So the next one here, so as I reach the limit, I'm gonna put it at what, 450, right? And then other 2 solution there, then I have 32.89 megawatt mismatch now. So I have to do one more iteration over here. This iteration is lambda delta 2 again. I have this value here and put it back is 9.4 with the previous one. Then I now see that, look at here, I'm not changing that one. Then I found that my other 2 should generate 325 and 200 megawatt, and if I put back together delta P is 0, that means I reach the solution, right? So now that means my power plant should generate 450, 325 and 200 megawatt right here, and my incremental fuel cost is this. If I put it back into the equation over here, now this is the total cost of my 3 power plant generating 925 megawatt. So what is this thing here? When you have the limit on generation, if we hit the limit, is upper limit or lower limit, your power plant should produce the constant output at that limit, and other power plant should adjust their output to meet the demand. All right. So that's all for this part here. I'll see you in the class. And if we have time end of the semester, I'd like to discuss what is the generating limit as well as the line loss, including into the optimization. Hopefully you'll have some time. If not, you can explore yourself if you have interest in optimization. Thank you very much and see you soon.